Alright, today we will be learning more about the oceans. Our goals are going to be that I can explain ocean salinity, temperatures, density, currents, and gyres. I can define thermohaline circulation. Those are your two goals. So let's go back up to the first goal real quickly. And again, salinity is how much salt content is in the ocean's waters. Temperatures, we're talking about how warm or cold something may be. Density, and we're going to be referring to the density of the waters and density of the air. And cold air is more dense than warm air, and salt water is more dense than fresh water. And we'll eventually get to talking a little bit more about currents and then what are gyres. The second goal says I can define thermohaline circulation. And that definition is written out for you to add to your notes. How temperature and salt content moves through the oceans. So how is wind helpful to Earth? And you can think about this in your own experience, but how has wind been helpful to you? Well, for Earth and many people on Earth, wind is the fastest growing source of electricity in the world. It's often one of the most least expensive forms of renewable power available at this time. Some experts say that it can sometimes be the cheapest form of any kind of power. Generating power from wind leaves no dangerous waste products behind. Best of all, its supply is unlimited. So we're going to talk about two things. We're going to talk about something called sea breeze, and next we'll talk about land breeze. Sea breeze. I want you to take a look at this picture and actually draw it into your notes. As you're drawing it into your notes, I want you to notice and see if you can pick out two processes that we've talked about in class that are occurring in that picture. On a warm summer day along the coast, this differential heating of the land and sea leads to development of local winds called sea breezes. As the air above the land is heated up by radiation from the sun, it expands and begins to rise, being lighter than the surrounding air. To replace the rising air, cooler air is drawn in from above the surface of the sea. This is sea breeze and can offer a pleasant cooling influence on hot summer afternoons. So the processes that we were talking about, one of them I circled in red. And that is how heat transfers through empty space. And that would be how the sun transfers its heat from where it is all the way to our surfaces of our oceans and our land. So that is radiation. That's one of the processes, and that's one of your word wall words. The other process that I wanted you to notice in your picture is convection. This circular movement of air. You have air that's being warm air that is rising. As it gets into the atmosphere, the higher you go, the cooler it is. So then it begins to cool and it starts to descend or sink. As it comes across the surfaces of Earth, the oceans and the land especially, it starts to get warm again and it starts to rise. That is called convection. That circular movement of air. That is how heat gets transferred in the atmosphere by moving that warm air and that cool air. So let's talk about a second situation, and we call that land breeze. Land breeze occurs at night when the land cools faster than the sea. In this case, it is above the air above the warmer surface water that is heated and rises, pulling the air from the cooler land surfaces. Now someone might ask, why is the ocean warmer than the land? Think about how deep the ocean is, and think about all that water that is warmed. It's going to take a long time for all that water to cool. Whereas the land, if you were to think of having a lamp heating the table that you're sitting at, the surface of the table would become really warm after a while, that lamp's heat beating down on the surface of your table. But if you were to put your hand underneath the table and feel what that surface feels like, it would be cold. Whereas if you put a glass of water under a heating lamp, not only is the surface of the water warm, the entire water in your cup is now warm. So if that helps you understand why the ocean remains warmer longer, I hope that does help. The process of convection still happens. We still have this cooler air that's being swept across the ocean. It's being warmed. As it's warming, it's rising, circulating through the atmosphere. The atmosphere, the higher you go, the cooler the air, so it begins to cool up there and eventually starts to descend again. And that process just keeps happening, and that movement of that air keeps happening as it warms and cools. And again, that is called convection. So what I want you to add to the very bottom of your notes now is that the oceans drastically affect the temperatures along shorelines. So when you're rich and happy one day and you got two houses, you got a beach house and you got a house in the city, your beach house is going to have different temperatures than the house in the city will, because the oceans affect that temperature drastically. How am I doing so far, Joel?
Are you done?
I'm done for now. Am I doing okay?
You want me to lie or tell the truth?
Tell the truth always.
Oh, fudge. Man, I can't lie.
Oh, shoot.
Truth don't...
All right, now we're going to talk about salinity. And you can go to a website called kidsgeo.com. And one important characteristic of water is that it is a superb solvent. Solvent means that other substances, such as minerals, can dissolve quickly and easily into it. Now, when talking about the ocean's water, we're going to mainly talk about how salt is dissolved there. The ocean contains a soup of many different minerals found across the surfaces of the earth, all dissolved into the water. These minerals make up about 3.5% of the total volume of Earth's ocean. By far, the most common mineral found dissolved in seawater is salt. I think you already know that, but let's make sure. The amount of salt dissolved in the water in the Earth's oceans is called salinity. Two very important factors determine how much salinity an ocean may have. The first is that how much evaporation is taking place. The second is how much fresh water is being added. So if water is being evaporated, the salt is being left behind. As water evaporates, it leaves salts and other minerals behind. This causes the water left behind to be more salty. As fresh water is added, and it may be added in different ways. Could be a river or lake or rainfall or melting glaciers. The salinity of the ocean starts to decrease when you add fresh water. Talk about ocean's temperatures. There's an iceberg. The waters toward the equator are quite warm. In fact, surface water temperatures can be as high as 80 degrees Fahrenheit. But as you travel towards the poles, that water starts to decrease in temperature. And when you reach the poles, it could be as cold as 28 degrees Fahrenheit. Talk about the way waters move in the oceans. The waters of the oceans are for the most part in liquid form. The waters of the oceans can be mixed up by a number of forces, including wind, splashing against rocky surfaces or shores, swimmers, and boaters. However, the items mentioned above create a very minimal amount of mixing. Three important forces create a much more prevalent mixing of the ocean's waters, causing the waters to move about from one place to another, as though a big giant were shaking them in a water bottle. These forces are waves, currents, and tides, and we're going to focus on currents in this unit. Gyres. These are a type of ocean current, and it's a closed circular current that's moving warm and cold water around the world. And this is a convection current. Colder water moving in and pushing warmer water about. I also want to point out the size of the oceans. If you look at here, this is the Pacific Ocean. And here is the Atlantic Ocean. You have several other oceans, but what's important to know is that the Pacific Ocean holds more than half the world's salt water. Let's talk about why the waters move in the ocean. Energy and matter are continually exchanged between the ocean and the atmosphere, and these processes drive the ocean and the atmospheric circulation. Evaporation and precipitation plus heating and cooling bring about the changes in the temperature and salinity of surface waters. Density changes that accompany the changes in temperature and salinity can also cause water to sink and rise in the ocean. Later on, we're going to talk about upwelling, and that's that vertical movement, that up and down movement within the surface layers of the ocean. So let's put a few of the things we've talked about into thinking maps. Changes in temperature and salinity in the surface waters. Well, those three things would have been evaporation. That can change the salinity. Precipitation, or the heating and cooling. Lastly, density in ocean waters can be affected are affected by the salinity and the temperature of those ocean waters. Lastly is that great ocean conveyor belt. There's no real conveyor belt sitting at the bottom of the ocean, but it's a concept that helps us understand how these waters move. The Great Ocean Conveyor Belt carries warmer, and it also carries less salty water from the equator to the poles. The colder waters and the saltier waters are carried from the poles back to the equator. Colder water and saltier water is more dense than warmer water or less salty water. And that's where we're going to end today.